Good morning, guys. Today we're going to be covering Unit 7's Formative Assessment. So, one of these videos are the things that you guys need to study for this Unit 7 test. The Formative Assessment, the Practice Test, and then the Unit 7 Review. Those three things will be the best things that you guys can study to prepare for this upcoming test. So with that being said, let's go ahead and jump right in. The first question, we need to simplify radical 48. Now, in order to do that, we're going to go ahead and start by creating a factor tree of 48. These are all the numbers that will multiply to be 48, and we want to break it down into all the primes. So the first one that we have is 2 times 24. That will equal 48. 2, of course, is prime. So I circle it. 24 can be broken down into 12 times 2. 2 is prime as well, so I'll circle 2. 12 can be broken down into 4 times 3. 4 not being prime, 3 being prime. And then lastly, 4 can be broken down into 2 times 2, both of those being prime numbers. So now that we have all the prime numbers that will multiply to give us 48, I put them all underneath the same radical. So now I have radical 2 times 2 times 2 times 2 times 3. If we have a pair of numbers or variables underneath the radical, then I can take a number out. So I see that we have a pair of 2's, we have a second pair of 2's, and then just a single 3. So with those pairs of 2's, I can go ahead and take those out of the radical, leaving us with 2 times 2 times radical 3. Again, only one number is taken out of each pair, so that's why you only see 1, 2 from the red pair, 1, 2 from the green pair, and then, of course, if it doesn't have a pair, it stays underneath the radical. So that's why the 3 is still there. Lastly, we just go ahead and we multiply and simplify this all out. 2 times 2 gives us 4 times radical 3, giving us our final answer, 4 radical 3. Next up, we have radical 75 minus radical 27. So for this problem, we do the same type of thing. We do the same situation. So we break these down into all the prime numbers. Now, before I continue on, I just want to mention, go ahead and pause the video before each problem, try out the problem on your own, and then go through it and check the video for your answer. This is just to help you guys prepare for the test, so keep that in mind. If you're not sure of the concepts, check out our previous Unit 7 videos, because that will have all the information in there for you guys. So, for radical 75, I can break down radical 75 into 25 times 3, and I can break 25 down into 5 times 5. All three of these now being prime numbers. For radical 27, I can break that down into 9 times 3, and then of course I can break 9 down into 3 times 3. Again, all prime numbers, just what we're looking for. Since they're all written in primes now, I can go ahead and put them underneath the square root symbols. So I'm going to have the square root of 5 times 5 times 3 minus the square root of 3 times 3 times 3. Again, they just got put underneath the radicals. At this point, if we have a pair of numbers that are the same, we can take them out of the radical. So I have a pair of 5's, and then I also have a pair of 3's. So therefore, this would give me 5 radical 3 minus 3 radical 3. Well, since they have the same radical, whoops, sorry about that, I need to go all the way back through this. Since they have the same number underneath the radical, that means that I can subtract the numbers out front. So therefore, 5 radical 3 minus 3 radical 3 will give us our final answer of 2 radical 3. Of course, the radical will not change when we subtract. It's just the numbers out front that will be subtracted. So again, the radicals remain the same. Next up, we have 30 over radical 5. We want to go ahead and simplify this. So we need to rationalize our denominator. So to do that, I'm going to multiply this entire number, 30 over radical 5, by 1. And the way that I'm going to multiply by 1 is by multiplying by our denominator over our denominator. So I'm multiplying by radical 5 over radical 5. Again, anything divided by itself is just 1. So I'm not changing the number at all. Now when I multiply straight across. 30 times rad 5 is 30 rad 5. Radical 5 times radical 5, well, that's the same as radical 25. And of course, the square root of 25 would give us 5. So the radicals basically cancel each other out here. Now at this point, I can go ahead and simplify the numbers on the outside of the radical. So 30 divided by 5 will give us 6. So our final answer is 6 radical 5. Next, go ahead and solve for x. We have x squared plus 7x equals 30. So we're going to go ahead and solve this by factoring. First thing I'm going to do is I'm going to subtract 30 from both sides. So leave us with x squared plus 7x minus 30 equals 0. Now that we're in standard form of a quadratic, meaning we're in the form of ax squared plus bx plus c equals 0. Now that we're in this form, we can factor. So the first thing I check for is a greatest common factor between all three terms. And there isn't one. So I move on to my next step. I take my a value, I multiply it by my c value. 1 times negative 30 is, of course, negative 30. Next, I look for numbers that add to be 7, our b value, and multiply to be negative 30, our a times c value. So I list out all the factors of negative 30, all the numbers that will multiply to give us negative 30. We have 1 in negative 30, 2 in negative 15, 3 in negative 10, 5 in negative 6. Then all the opposites, negative 1 in positive 30, negative 2 in positive 15, so on and so forth. Out of all these pairs, which one will add up to be positive 7? Well, there's only one that will do that. That would be negative 3 in positive 10. So next up, I write out my double bubbles, and the only thing that I'm going to put in both of these bubbles to get started is the variable that we're working with. In this case, it's x. So I have my double bubbles set equal to 0 still. That hasn't changed. And then I just put my variable that we're working with, in this case it's x, into both bubbles. From here, I take my two terms, negative 3 and positive 10, and I'll put each one inside the bubble. So I'm going to have x minus 3 times x plus 10 equals 0. Now, of course, I can set up my two equations at this point. Each parentheses gets its own equation. X minus 3 equals 0. X plus 10 equals 0. From here, we solve both of these equations, giving us x equals positive 3 and x equals negative 10. And those are our two final answers for this problem. Next up, go ahead and solve for x. We have x squared plus 3 radical 2 squared equals radical 26 squared. So if we look at this problem, it looks like Pythagorean's theorem. So I'm just going to go ahead and solve it just as is. So since the entire parentheses is squared, each number is getting squared within it. So this will give me x squared plus 3 squared times radical 2 squared equals radical 26 squared. Now, of course, the radical and the square will cancel each other out, giving us x squared plus 9 times 2 equals 26. Simplifying on the left side of our equation, that will give us x squared plus 18 equals 26. At this point, we want to get x squared by itself, so I can subtract 18 from both sides, giving us x squared equals positive 8. And then to get rid of the square, so that x is by itself, I take the square root. So therefore, x is equal to the square root of 8. Of course, we're going to have plus or minus out front, because I don't know if this is a distance or not. Right now, it's just inside of an algebraic equation, so I don't really know if I'm going to have a positive or negative answer at the end. So I'm going to take both. From here, I'm going to simplify this radical. So I'm going to break it down into all the prime numbers. So radical 8 turns into radical 2 times 2 times 2. Of course, since I have a pair of 2's, I can take it outside of the radical, giving us x is equal to plus or minus 2 radical 2. And that's our final answer. All right, let's go ahead and move on to our next problem. Solve for x. This time we have x squared equals 9x. The first thing that we want to do is we want to get all the x's on the same side of our equation. So I'm going to subtract 9x from both sides. That'll leave us with x squared minus 9x equals 0. At this point, we're going to go ahead and look for a greatest common factor between the terms on the left side of our equation. So what's the biggest number or variable that goes into both x squared and negative 9x? Well, in this case, it would just be x. So I have x times x minus 9 equals 0. Again, I just divided both of these terms by our GCF of x. From here, if it's outside the parentheses, it gets its own equation. If it's inside the parentheses, it gets its own equation. So we have x equals 0 and x minus 9 equals 0. From here, I can solve for both of these equations. For x equals 0, it's already solved. For x minus 9 equals 0, I can add 9 to both sides, giving us x equals 0 and x equals positive 9. So those are our two final answers. All right, next up. Starting at point A, Buggy walked due north for 1.2 miles, due east for 3.1 miles, and then 1.7 miles north, ending at point B. To the nearest tenth, find the length of the segment from point A to point B. So, starting at point A, he walked 1.2 miles north, so therefore I can draw in a picture walking up north. For 1.2 miles, we'll be walking upward on my picture. So there's A going 1.2 miles north. From there, he travels east 3.1 miles, and then lastly travels 1.7 miles north once again, ending at point B. So, at this point, I want to find the distance from point A to point B. So I can go ahead and create a right triangle out of this. Now we have one leg is 3.1 miles. That's how far he walked east. And then for the other leg, we have 2.9 miles. We got that by adding 1.2 and 1.7 together to give us a grand total of 2.9. So from here, we can use Pythagorean's theorem. 2.9 squared plus 3.1 squared equals AB squared. If I have two sides of a right triangle and I need to find the third side, I can always use Pythagorean's theorem. 2.9 squared plus 3.1 squared will give us 18.02. And then to get rid of the square, we take the square root of both sides, giving us AB is equal to 4.2 miles total. So again, if you ever have two sides of a right triangle and you need to find the third side, Pythagorean's theorem will always work, but it must be a right triangle. All right, next up. We want to classify a triangle with side lengths of 8, 11, and 14 as either acute, right, or obtuse. Now, in order to do this, we're going to use the converse of Pythagorean's theorem. A squared plus b squared equals c squared, where c is my longest side length. And in this case, 14 is the longest side, so it will be on one side of the equation by itself. We need to determine which symbol this is. So to do that, we just evaluate these numbers. 8 squared is 64, 11 squared is 121, and 14 squared is 196. 64 plus 121 will give us 185, which is less than 196. And if the sum of my two sides squared is less than my third side squared, then it's going to be an obtuse triangle. If those sides were greater than the side of my third side squared, then it would be acute, and if they were equal, then it would be a right triangle. All right, let's go ahead and move on to some special right triangle problems. So first off, we're going to solve for side length C. So, looking at this, I see that we have a 30-degree angle and a 90-degree angle, so there's two different ways that we can solve this. We can either use 30, 60, 90 special right triangles, or we can use trig functions, SOHCAHTOA. I'm going to go ahead and solve some of these in both ways. So I'm going to start by solving using special right triangles. So since this is a 30, 60, 90 triangle, I can draw a similar 30, 60, 90 triangle right next to it. The side opposite 30 is x, side opposite 60 is x radical 3, and the side opposite 90 is 2x. Looking at this, I'm going to set up my corresponding sides. I see that we have a side length of 2, and that corresponds to the side length of x. So therefore, I can say 2 equals x. From here, we're trying to find side length C. Well, C corresponds to 2x. So therefore, I can say C equals 2x. And I can solve for C if I solve for x. Well, we already solved for x. We found out that x was equal to 2. Therefore, C is equal to 2 times 2, or just 4. And that's our final answer. Next up, find in simplified radical form an altitude of the equilateral triangle shown with a side length of 8. So if I know that this is an equilateral triangle, I know that all sides are going to be the same measurement, so they're all 8. And I also know all angles will be congruent. They're all going to be 60 degrees. So if that's the case, then this would create a 30, 60, 90 triangle when I draw my altitude in. Because that altitude will bisect the angles because it's equilateral, meaning that 60-degree angle now turns into two 30-degree angles. Further, that side length of 8 will be cut in half, making each side length 4 on the opposite side. Further, if I don't trust that number, then of course I can use a special right triangle in order to make sure that I'm doing it correctly. So I draw my 30, 60, 90 triangle. Side opposite 30 is x, side opposite 60 is x rad 3, the side opposite 90 degrees is 2x. Looking at this, I know that all side lengths are 8 on this triangle, so therefore I can say 2x equals 8. Solving for x will give us the side opposite 30 degrees, so dividing both sides by 2 gives us x equals 4, which we said earlier. We said that that side length would be 4, so we are doing it correctly. Lastly, we just need the altitude. Well, the altitude is equal to x rad 3, and we know that x is equal to 4. So therefore, our final value for our simplified radical form for the altitude of this triangle is going to be 4 radical 3. Of course, on the test, you'd need it as a decimal, so you just enter that into your calculator, and that would give you on your calculator 4 rad 3 is equal to 6.9. All right, next up, we're going to go ahead and find f. Now, I'm going to use SOHCAHTOA for this one, but again, you can use special right triangles, or you could use SOHCAHTOA here. It doesn't really matter. It's totally up to you on which method you want to use. So, since I'm using SOHCAHTOA, I look at the angle that they give me. They only give me this 60-degree angle, so I label my triangle off at that 60 degrees. Opposite would be 9, hypotenuse would be f, adjacent would be blank. If I have opposite and hypotenuse, then of course I would like to use sine. So sine of 60 degrees is equal to opposite 9 over hypotenuse f. From here, we're just going to go ahead and solve for f. I can do that by multiplying both sides of my equation by f, giving me f sine of 60 degrees equals 9. Then to get f by itself, I need to get rid of sine of 60. So I divide both sides by sine of 60, giving me f equals 9 over sine of 60 degrees. That is what I want to enter into my calculator. When I enter into my calculator, I'll get f is about 10.4 units. And if you used special right triangles, then that is equivalent to 6 radical 3. So if you got either answer, you are correct. Of course, if you enter this into your calculator, you get 10.4. All right, next up, we're going to go ahead and find the cosine of angle A. So angle A is right over here. And if we look at our triangle, we already have 2 sides. We are just missing that third side length. So I'm going to go ahead and start by finding out what AC is equal to. Looking at AC, that is one of the legs. It's not the hypotenuse. So therefore, I have 8 squared plus AC squared equals BA squared. Now give me x squared plus 8 squared equals 17 squared. And then just go ahead and squaring these values. That'll give us x squared plus 64 equals 289. From here, we want to get x squared by itself, so I subtract 64 from both sides, giving me x squared equals 225. And then we go ahead and we take the square root to get rid of that square. Taking the square root of both sides will give us x is equal to the square root of 225, which is 15. So we now know this side length. From here, we're going to be using cosine of angle A. So focusing in on angle A, we need to label our sides. So again, we're using adjacent and hypotenuse. So cosine of angle A is equal to adjacent, which is going to be 15, over hypotenuse, which is 17. So that's our final answer. It's just looking for the ratio, 15 over 17. All right, next up. The angle of depression from an observation tower to a fire is 28 degrees. The height of the tower is 90 feet. How far is the tower from the fire? So here's my picture. We have our tower, we have a fire going on in the forest, and they see the fire from the tower. They're like, oh, there's a fire going on over here. Now, the first thing that we need to do is we need to draw our triangle. They're telling us that we have an angle of depression. So if I have an angle of depression from my tower, because that's who's doing the observing, I'm going to draw outward. And then since it's an angle of depression, I draw down. Always draw out first. If it's an angle of elevation, I would draw up. If it's an angle of depression, I draw down. So here's my triangle. And then we just label what we know inside the triangle. First off, the tower is 90 feet tall, so I know that from the ground to the top of the tower to where they are observing is 90 feet. I know that the angle of depression is 28 degrees, and we're looking for the distance from the tower to the fire. We'll call that x. From here, we're just going to label our triangle with what's given because we're using right triangle trig. So we label what we have. Opposite is 90, adjacent is x, hypotenuse is blank. Since we have opposite and adjacent, we're using tangent. So tangent of 28 degrees is equal to opposite 90 over adjacent x. From here, we just want to solve for x. So I multiply both sides of my equation by x, give me x tangent of 28 equals 90. From here, I want to get x isolated, so I divide both sides by tangent of 28 degrees. That leaves us with x equals 90 over tangent of 28. That's what you want to enter into your calculator. Plugging that into your calculator will give you your final distance of x being about 169.3 feet. So therefore, the distance from the tower to the fire is almost 170 feet long. All right, let's go ahead and finish up. Here's our final problem of the day. We're going to go ahead and find x. So looking at this, we have a square here. And on a square, I know that all sides are the same. So each of these side lengths is x. Now further, this diagonal here would cut these angles in half. So these 90-degree angles turn into both 45 degrees. So therefore, I can draw a similar right triangle here. And I'm just going to say that we have y, y, and y rad 2. And the reason I chose those values is because I don't want to get confused with x. So first off, the only side that has a value on our original triangle is the diagonal, 86. So I can say 86 equals y radical 2. From here, I can solve for y. If I divide both sides by radical 2, I'm left with y equals 86 over rad 2. But we're not quite done here. Because at this point, I'm going to go ahead and rationalize this denominator because I can't have a radical down here. So I multiply both the numerator and denominator by our denominator, by radical 2. That turns into 86 radical 2 over 2. From here, I can simplify the numbers outside the radical. 2 will go into 86 43 times, giving us x is equal to 43 radical 2. And that's our final answer. All right, guys, thank you so much for watching today. If you have any questions, please let me know, but have a great